In this video we have two objectives here. We need to learn what a node is and what a loop is in a circuit diagram. And this takes a little bit of time getting used to, but once we see it we'll be able to really start understanding what the difference is between a node and a loop. I mean, the names kind of give you an idea. But let's go ahead and write a definition down here for a node here. A node is basically a connection of two or more circuit elements. So let's just dive in and look at an example here. I'm going to draw a circuit. And all we're going to look at in this circuit is how many nodes does this circuit have. Now, one thing that we should maybe emphasize before we dive into this, a wire is not considered to be a circuit element. So in other words, circuit elements are going to be like resistors, power supplies, and when we get into them, capacitors, inductors, and there's more. We have transformers, diodes, transistors. Those are all considered to be circuit elements. And now again, wires are not considered to be circuit elements. So if we look at this here, well, what we can clearly see is there's a node right here. You know, that's connecting this voltage source up to resistor 1. And then we can also clearly see, well, there's definitely a node here because that's connecting R1 and R2. But you also have to be careful here. Some people want to say that this right here is an additional node. But remember, wires are not considered circuit elements. So, whoops, erased too much there. There we go. So remember here, wires are not considered to be circuit elements. So this right here that we're looking at is connected to this node by a wire. So that's really not a different circuit, a different node. It's the same node. So we have one node here, and this node connects R1, R2, and R3 together. And then of course we look at the circuit one more time here. We also have a node down here at the bottom, which connects the negative side of the voltage supply, R2, and then R3. And that's all the nodes we have. So this circuit has 3 nodes. Now, we often draw the circuit this way to make it easier to kind of visualize what's going on, but there's no reason we couldn't have drawn the circuit the following way. where we don't really have, these straight out wires where we kind of connect the R2 and R3, which makes it, I think, a little bit clearer that they share the same node here. This node here down here and this node right here. And of course, the third node is still over here. I mean, we could redraw the circuit like that, but often, especially when we're doing some analysis on these circuits, that actually is kind of messy and not really clear on how things are done. And so we often draw the circuit like what we have up here instead. So let's look at one more example with nodes here. And we're going to answer the same question here. How many nodes does this circuit have? And once you get really good at this, you'll be able to kind of just by inspection see it. I always, for some reason, like to start wherever there's a dependent power supply, or I'm sorry, independent power supply. Doesn't really make a difference. So there's a node right here, and I kind of like maybe to highlight here, okay, that connects this circuit element, and this circuit element together. Okay, so then if I kind of go along here, well, there's the other side of, on this resistor 1 here, there's the other side of this resistor 1, which is connected up to things. When that's connected up to, well, we've got resistor 1 here, it's connected to resistor 2, and then it's also connected to resistor 3. And then following here, we can say, oh wait, the bottom is a node, and that's connected to resistor 2, the negative side of the dependent or the independent power supply, and the negative side of the independent power supply. And then we have still one more node here, and that's this one here connecting R4 and R3. Now, it's not necessary to do these little dots that I've done here, but notice that I'm done counting all the nodes, and there's a dot on each side of the circuit element. And that's because, well, each side of the circuit element should be connected to something, so we can clearly see how many nodes we have. So in this case, we have 4 nodes. Now, the circuit simulator that we often use, or the free versions of circuit simulators out there, the main thing that limits you as far as what you can do with circuit simulators, as far as the free versions are, is the number of nodes your circuit can have in the simulation. So that's different depending on the software program, but the full versions, of course, don't have a limit on the number of nodes because that's the whole point of the full version. But the free versions typically have a limit on the number of nodes a circuit can have. But typically for a course like this, any kind of free circuit simulator is going to have plenty of nodes to simulate any circuit we'd be looking at in this course. Okay, the other thing we should talk about here is loops. Well, loops, I think it's harder to describe in words what a loop is, but a loop is basically a closed path containing 2 or more circuit elements. And so loops, there's a lot of different ways we could draw a loop here. So let's look at a circuit. You need a circuit to really be able to draw loops here. resistor, right, where I put a wire. Now, the temptation is to sometimes say, oh, well, there's, clearly only like two loops in this. And I'll show you what we mean by two loops. So basically, you start somewhere and you have to run through all the circuit elements. So I'm going to make a loop here. I'm going to come up through that voltage source. I'm going to go through this resistor. And then I'll come down through R2 and then come back across this wire and wind back up. So that would be a loop. And then I could say, well, there's another loop here. If I start in R2, kind of come up through R2, go across this wire, down R3, and then cross this wire and back up, that's a second loop. But there's actually a third loop we could do as well. I could start at the power supply, come up, go through resistor 1, go all the way through this wire, down resistor 3, all the way back across, and have that be a loop. Now, I will be honest, we don't typically draw loops and close paths like this. Typically, the way we'll draw a loop here, if we're doing some problem with circuits, if we draw the same circuit here, is we will often draw these loops in the following thing, where I have basically I'll put an arrow giving it a direction, because we're going to need a direction of the loop. And then I'll draw another loop here giving a direction. Now, that's the two loops here. If we wanted to do the third loop, we typically, you might say, oh, just do up here, but we have to give some bigger indication. So we might actually draw most of that loop out to make sure it's clear what this third loop is doing. All right, so those are loops and nodes, and that's all we really want to talk about in this video. In the next lesson, we'll start talking about how we can use these loops and nodes to do circuit analysis.